So, as I mentioned in class on Tuesday, that I decided to flip these this lesson around. We're doing 5 to 5 outside of class. So this is solving and applying the quadratic formula, and we need to figure out how to do this. Now we have all the strategies in the world. So we have factoring using the zero product property, we have used the quadratic formula, and we have complete the square. So the question is, when should we do what? And the idea is to just figure it out. So we're just going to look at 6 problems in this video, and then when we are done with these 6 problems, we will also take a look at some more practicing problems. But let's just start with these 6. So what we have here is 6 problems. Okay, no big deal, and all the methods in the world. So the first one I'm going to look at, the first one that's easiest to solve to me is C, because it's already factored. So I'm going to start with C. It's the easiest. I know, I'm going to go all out of order and all sorts of stuff. So we're going to start with C, and I'm going to apply the zero product property because it's factored. In order to use either completing the square or the quadratic formula, I'd have to multiply everything back out. I don't want to do that. It's too much trouble. It's too much work. I don't want to do that. So I'm going to go ahead and just then set each part equal to 0. Okay, and so what are my 2 answers? Go ahead and respond. Be right there. Okay, so we have 3x equals -4 and x equals -4/3. And from this one I have 2x equals 1 and x equals 1/2. And so those are my 2 answers. And remember, it's or because, I don't know if I've said this, so maybe not remember, but it's or because I have not, they can't be the same thing at the same time. That's why we say plus or minus, because you can't have both at the same time, in case you're curious. Okay, so D, E, and F are a little bit funky because they're not equal to 0. If I try to factor this, I'm just going to think 27 and 12. 27 is 9 and 3, or 1 and 27, and those don't add up to make 12. So I'm going to complete the square or quad formula. So we're going to do an abbreviation key over here. If we're going to factor to zero product property, that's what we will call it, just CPP. If we're going to complete the square, we will CS. And if we're going to quad formula, we'll just do QF. Okay, so that's going to be our abbreviations. Now I can either use the quadratic formula or complete the square on this one because it doesn't factor. It's the first thing I check. I personally always check factoring first, because if it's factorable, I don't want to waste my time. And I'm really good at factoring, so again, I can check it really fast. So it's no big deal. It doesn't take any time. Now, because there's no number here, and that is an even number, I'm going to probably complete the square just to remind us how to do it. So I'm going to go ahead and complete the square. And so x squared plus 12x squiggle equals -27 squiggle. And so squiggle is I'm going to split this in half so that, this factors into x plus 6, and plus because it's positive, and 6 because it's half of 12. So for that to happen, this number needs to be 36. And how did I get 36? Because 36 is 6 squared. So that this can be squared on the left, squared on the right, and double in the middle. So if I add 36 over here, I have to add it over here as well. Oh, wait, 9 and 3 do make... Nine and 3 add to 12. I don't know what's wrong with me. No idea. Sorry about that. 9 and 3 totally make 12. Alright, so 9 and 3 make 12. And I should have factored this. But I'm already here, so let's keep going. X plus 6 equals plus or minus 3, because the square root of 9 is 3. And so x equals negative 6 plus 3 or minus 3. And so x equals negative 6 plus 3 is negative 3. Negative 6 minus 3 is negative 9. I should have factored 9 and 3. So I'd have x minus 9 and x minus 3 equals 0 and x equals 9 and 3. So I show, well, wait, positives, excuse me. I should have factored that. I'm sorry. I'm a little tired. This one, because I have another thing that's not, I'm going to isolate x squared. Now, I can absolutely try to factor this. It's totally factorable. I can factor it very quickly because I recognize it's the difference of two squares. So I've got 2x plus 11 and 2x minus 11 equals 0. But let's say you don't recognize that. And you're sitting there going, I have no idea what two numbers add to make 0, but multiply to make 484. Like, you're stuck. Okay, so we're stuck. I'm not stuck because I recognize the pattern. But if you're stuck, we can also do this. So I'm going to try it alternatively. So we would have 4x squared equals 121, adding 121 to both sides. So x squared equals 121 divided by 4. So x equals plus or minus the square root of 121 divided by 4, which is plus or minus the square root of 121 over the square root of 4. And again, you don't need to write this step down. I'm just trying to explain what I'm doing. So plus or minus 11 over 2. The square root of 121 is 11. Square root of 4 is 2. And those are my two answers. And if I continued with my factoring over here and applied the zero product property, I would get 2x equals negative 11 and x equals negative 11 over 2 from the first one. And the second one solves similarly. And honestly, as much as I like to factor, this way's faster to me, because then I don't have to solve it twice. It's so much trouble. This one I just solved it once. Again, it's up to you. All right, so far we've done everything two ways except for C. Let's try D. And D, I need to gather everything together because it's go wompy. I need it to be equal to 0. So the first thing I do always is make sure it's equal to 0. Now there are a couple exceptions, and that's really when I'm going to complete the square, but let's not worry about that. So we're going to go ahead and minus 8x from both sides. And so we'll have x squared minus 8x because it cut in front of the 12 plus 12 equals negative 4. And now I'm going to go ahead and add 4 to both sides. And we have x squared minus 8x plus 16 equals 0. Now I'm there. And so in that sense, I'm going to go ahead and either factor or complete the square or use the quadratic formula. Numbers that multiply to make 16 but add to make negative 8 are negative 4 and negative 4. So this does factor. So x equals 4. Twice, if you will. Okay. Okay. Okay, we have 2 left. Okay. I've subtracted 60x from both sides. And again, it cuts in front. These numbers are big. The quadratic formula may be a little bit. Let's go ahead and try it. And if we remember, quadratic formula says that negative x is equal to plus or minus, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so here we go. X equals negative b. The opposite of b is 60 plus or minus the square root of 60 squared. Oh wait, 6 squared is 36. So 60 squared must be 3600. Okay. Minus 4 times 36 times 25. All over 2 times 36. So 60 plus or minus the square root of, I wish I'd factored, 3600. And that's, oh wait, no I don't. 4 times 25 is 100. Times 36, oh, 3600. 2 times 36 is 72. 3600 minus 3600 is 0. So we're left with 60 plus or minus the square root of 0 over 72, which is equal to 60 over 72, because plus the square root of 0 minus the square root of 0 is going to be the same thing. Square root of 0 is 0. And so 60, 12 goes into both those numbers. I get 5 over 6. If I looked at factoring, squared on the left, squared on the right, and that's 6 squared and 5 squared, and 6 times 5 is 30, doubled in the middle. Your decision, your call. All right. This last one, 20x squared minus 32x minus 45. Again, moving everybody over. There's not a number that will divide into all the terms. That's dreadful. By the way, there wasn't one back here either. I just didn't mention it. Sorry about that. Not perfect squares. Don't want to complete the square because of the 20. So quadratic formula, here I come. Go ahead. See what you got. I plugged it in, now it's your turn. All right, so I went ahead. 32 squared is 1024. And 4 times 20 times 45 is going to be positive because it's negative and negative. So positive 360. Adding them together, I get 4624. On my calculator, I took the square root of 4624, and I got 68. So I didn't know. And so 32 plus 68 is 100 over 40. And 32 minus 68 is negative 36 over 40. 100 divided by 40 is 2.5. And even though, yes, I can totally put that as a fraction on my own, I'm going to just steal it. It's 5 over 2. And then 4 goes into both those, 9/10. Yep, 9/10. Negative 9/10. Now, this is a problem I would use the quadratic formula on instead of factoring, even though it's factorable. I would not come up with these numbers on my own. By the way, I can work backwards from this to the factorization if you want, but not necessarily. So that's your basic idea. Let me go ahead and see if we can get that answer on the screen. Okay. That's your basic idea. And then in the next, and we're going to go ahead and practice really quickly. We have all these problems. I'm going to go ahead and pull this under. And so this is just the directions say to use the quadratic formula on all of them, leaving you not to think. But if you can factor it quickly, feel free. I would not use completing the square on any of these first 4 problems because the middle term is odd on all of them. And then I've got leading coefficients on these 3. So again, you can factor them if you prefer, but I would not complete the square. So that's up to you. I will have answers for those in just a little bit. So go ahead and pause, figure out what you got. We'll do the same. Let's see what we come up with. Okay, I factored all of these. And again, it's up to you. Those are my answers. Okay, so that's one away. Now let's look at the four at the bottom. These you must use the quadratic formula on. There is no other option. I'm going to go ahead and do 5 with you slowly, and actually 6 with you slowly, and then also, so we'll do the evens. And then I'll leave you with 5 and 7 to do on your own. Okay. Okay, so ABC, first n squared plus 5n minus 9 equals 0, moving it over. A equals 8, B equals 5, C equals negative 9, X equals plus or minus, opposite of B, negative 5, plus or minus the square root of 25, because that's 5 squared, minus 4 times 8 times 9, 8 and negative 9, all over 2 times 8, negative 5 plus or minus 72 times 4, eight times minus 72. So 25 plus 288 all over 16. Plus 25, 313 over 16. 313, I can't think of, I think it's prime. Nope, okay, it is prime. So those are answers. And I'm going to write them separately, but you don't need to. You can write them once, but I need you to remember they are 2 answers, and it helps to kind of practice writing them twice to remember that. And of course, being careful about your sign. And I'm not going to go to decimal, I'm going to leave them right here. Okay, then let's do it. And by the way, what I was doing with 313 was trying to figure out if I could simplify the radical. All right, so this one, ABC, rearrange, 7k squared plus 9k plus 5, A equals 7, B equals 9, C equals 5, X equals the opposite of B, plus or minus B squared is 81, minus 4 times 7 times 5, all over 2 times 7, negative 9 plus or minus the square root of 28 times 5, 140. So I've got 81 minus 140 over 14, negative 9 plus or minus the square root of 81 minus 140, negative 59 over 14. And so, now that we've had complex number discussions, negative 9 plus or minus I, radical 59, 59 is prime, over 14. So whenever we have a negative sign under the radical, now we're going to pull out 9, unless I'm trying to find x-intercepts. So if I say x-intercepts, well, this doesn't have any x-intercepts, but it does have 2 solutions that are complex. And you can write them down separately or leave it in this format. I'll go ahead and do both. See, and I can't even bring myself to write it twice and look at plus -9 minus 5 radical 59 over 14. All right, so try 5 and 6, 5 and 7, and I'll talk to you guys soon. So I'll have answers for you another time. Actually, okay, I'll put the answers up. Just kidding. Okay, so first on this one, I completed the square. So I broke this up as 5 and 5. I moved this 10 over there. So the number had to be 25. And again, this is how much work I have to show to complete the square now. But I figured most of you would have tried the quadratic formula, so I did it. You might have stopped right here. I get it. But 140 can be simplified. And that's how I get the same answers. If you stop right here on the test, I'm going to give you full credit. So don't feel like because simplifying radicals is important. I really like doing it. But in our world of calculators, it's not as critical as it used to be. And then 7, negative, so I came out. That's it. Have a great day. We'll see you guys soon.